In this video, we'll examine how to run the one-sample t-test in SPSS. And here we have an example, as you can see on your screen, where we have a variable that's named math scores. And on this variable, we have the math scores for 15 different people. And as far as the background of this study is concerned, this hypothetical study, suppose that an educational researcher was interested in investigating the effectiveness of a new program that was designed to help 8th graders perform better in math. And what happened here is the kids that were enrolled in the program took it for 4 weeks, and then afterwards they took the math test. The scores for the kids who took the program are reported here, as I said earlier. Now the population mean of those who didn't take the program is 80. And we have the 15 kids who took the program. Now the question here for the one-sample t-test, we're going to use the one-sample t-test to evaluate whether or not the program makes a difference. If it does, the kids should score significantly different than 80. And the reason for that is because 80 is the mean for those who did not take the program. Okay, so we have our scores for the kids who did take the program, and we want to see whether these scores, and in particular the mean of these scores, are they significantly different from we could call it the untreated population mean of 80. So this is what we want to take a look at in SPSS. But before we begin, the reason why we want to use the one-sample t-test here is notice that we have one variable in SPSS. Or in other words, this is one sample of scores. The other t-tests, the independent samples t-test, the dependent samples t-tests, they both have 2 columns of data, as you'll see. But for the one sample t, we just have this one column of values. To run the one sample t, we go to Analyze, and then Compare Means, and then select One Sample t-test. Okay, when you do that, this dialog box opens, and what we want to do in SPSS, as always, is our variable or variables are on the left. In this case, we only have one, so it's on the left. We want to move it to the right. And in this case, we'll move it to the test variables box. So go ahead and move that there. And then one thing that's very important with the one sample t-test that is a bit unique to this test alone compared to the other tests we'll look at is that right here in this test value box, we want to make sure that we put the value that we're comparing our scores to. So the population mean that we're comparing our scores to. And if you think about it for a minute, you should recall, hopefully, that the population mean was 80. Remember, the population mean of those who didn't take the new program was 80. So we are going to compare our scores here to the mean of 80. So we're going to put in 80 as our test value. Okay, so with 80 in there, we're ready to go. But one more time, it's worth reinforcing here, this is a very common mistake I see in SPSS with students, and that is they'll leave the 0. They'll leave that default value in the test value box. And you know what that will test if we did that? That would test whether these values are significantly different from 0, which we certainly would expect. But the real thing we want to test is, are they different from 80? Okay, so make sure you put the untreated population mean in the test value box. Okay, with that being said, let's go ahead and click OK. We're ready to go. So the one sample t-test runs in SPSS, and we get this output that consists of just 2 tables. And this first output contains our descriptive statistics. Let's take a look at this for a minute. Notice here we have a variable named math scores. We had 15 people on this variable, as we already saw. Now notice the mean here is 86.33. That's the mean of our 15 people, with a standard deviation of 8.11. Okay, so we're going to compare basically this mean of 86.33 to the test value of 80 in this next table. So let's go ahead and look at this table now. And here we get a number of values. We have our t value, which we'll talk about shortly, our df, our sig two-tailed, and then mean difference, and so on. First of all, what we want to do is zero in on this sig two-tailed value. Whenever we conduct a hypothesis test in SPSS, we're going to use a decision rule, such as the one stated here. And we'll always use the following approach, but it will vary depending on whether we're using alpha 0.05 or alpha 0.01 or some other alpha value. Here I want to use alpha 0.05 for our test, and we're also going to use a two-tailed test, which means we're allowing for the possibility that the program either helped students to do better, or maybe the program didn't turn out as intended, and students who take it actually do worse. So we're going to allow for that possibility. So we'll conduct a two-tailed test that allows us to determine whether scores are significantly higher than 80 or significantly lower if that, in fact, turned out to be the case. Okay, so we'll use alpha 0.05, and we'll use a two-tailed test. Now that's something that we want to decide before we begin the test. Okay, so we'll just assume that we already did decide that, and now we're going to interpret it. In practice, though, you always will decide that before you begin the test if you're doing a real study. Okay, so we have the decision rule here laid out here, and I'll be blocking this area here of the output, but we're not going to discuss that now, so don't worry about that. So our decision rule is as follows, and you always do it like this. It's really pretty straightforward when you get this down. One of these two conditions is true, either this one or this one. So let's read through the two and see what they say. If p is less than or equal to 0.05, the test is significant. And in this case, this means that the sample is significantly different from the population mean of 80. If p is greater than 0.05, the test is not significant, and that means the sample is not significantly different from the population mean of 80. Okay, and the question is that you may be wondering is, well, what's p? P in SPSS is sig two-tailed. Notice the two-tailed, that means this is the p-value for a two-tailed test, which is what I said we were going to use. But sig is the same as p. So when you see sig in SPSS, think p. Okay, so looking at our p-value, we see it's 0.009, and if you apply it to these two situations, you should see that 0.009 is smaller than 0.05, so we will conclude that the test is significant, or in other words, the sample is significantly different from the population mean of 80. So then the question is we want to ask ourselves is, okay, the students who took the new program did score significantly different than 80, and that was the mean of the students who didn't take the new program. So in other words, the program did something, it appears. The question is, are the scores better or are they worse? So at this point, what we want to do is go up to our mean. If you see our mean, notice that the mean of the 15 students is 86.33. So you want to ask yourself, is this mean higher or lower than the untreated population? Well, the untreated population was equal to 80. This is 86. So this suggests that the students scored or did significantly better on the math exam. So it looks like the program may be helping students perform better on this math exam. So what we'll do next is take this information and make a written statement about our results. To write the results, what we'll do is we'll go ahead and use the following values. We'll use the t value, the df, and the p value. And this df, by the way, it's just equal to the total sample size minus 1, or 15 minus 1 is 14. So the results could look something like the following. The students who took the new program, that's our 15 students, scored significantly higher than the untreated population mean of 80. And then here we write the APA format, which is T, that tells the reader the test we're using, it's a t-test. And then in parentheses we have the degrees of freedom next, which in this case are equal to 14. And then we write our t value, which here is equal to 3.02 rounded to 2 decimal places. And then finally we write p is equal to, and we put whatever the p is, which here is 0.009. Now you can state, instead of p equals 0.009, you can state p is less than 0.05. Recall this was our value of alpha that we used. But 0.009, stating the exact p-value, really is more informative, and therefore it's recommended. But if you have a class where you're instructed to write p is less than 0.05, that will suffice as well. So these written results in APA format. APA format stands for the format of the American Psychological Association. And it's a very popular, very commonly used format. This is one way to write it. It's, like I said, it's a very popular, common way of writing it. So that's what we're going to do here. Okay, so notice this statement. It says that the students who took the new program, they did score, it was significant, but it also says the direction. It says they scored higher than the untreated population mean of 80. And once again, because the test was significant, we went and looked at the mean of our 15 people, and this mean of 86 was higher than the mean of 80 for the untreated population. And that is why we said that they scored significantly higher. This concludes the presentation on the one sample t-test. Thanks for watching.